The final component we're going to be adding to the scene is the component manager. To do that, we'll add another empty game object. I'm going to call this component manager. The component manager can be found under Component, Dynamic Loading Kit, Main Components, Component Manager. So the component manager has several different responsibilities and allows us to do several different things that we wouldn't be able to do without it. Its first responsibility is to track all of the worlds and active grids in the scene and ensure that they are properly initialized at the beginning of the scene. However, note that only components on active game objects will be picked up by the component manager. The second responsibility of the component manager is to ensure that each active grid's persistent data is saved when required. So without this component manager, whenever you wanted to save the persistent data of an active grid, you would have to manually track each active grid in your scene and call its save method. Because we have this component manager which contains a list of all the active grids in the scene, we can simply call a single save method on the component manager, and it will in turn make sure that the persistent data for every active grid is saved. The third responsibility of the component manager is ensuring that worlds and active grid changes are saved between sessions. There are two types of changes. You can remove active grids or worlds during the game. So for instance, I could destroy this active grid, and that destruction will be saved, and the state of that destruction will be maintained to the next session. So this active grid won't magically just pop up in the next section. It will, well, it will actually, but the component manager will go ahead and remove it. In the same vein, you can also create active grids and worlds during your game and have those created components be maintained between sessions. So I could create a new world and have that world automatically created the next time I started my game. Of course, in order to do this, you'd have to save, call the save method on the component manager. The component manager also allows you to find active grids and worlds in the scene. So perhaps you know the ID of a world or an active grid. You can actually request that active grid or world using its ID from the component manager. Also, because the component manager is the only component which is concerned with actually initializing the save, we only need to reference our persistent data controller on the component manager. So without the component manager, we'd have to provide a persistent data controller reference to all of our active grids. And of course, the component manager has its own persistent data, which includes which inspector created active grids or worlds have been destroyed during your game, and which worlds and active grids have been created during your game. So the first thing we need to do is drag our persistent data controller that we created in a previous video onto the field labeled persistent data controller. This next option here, auto save data on game exit, simply specifies whether the persistent data of the component manager and all of the active grids in the scene should be saved automatically when the game ends. This includes when you exit play mode in the editor. More than likely, you'll want to only save your game when the player chooses to, so you want to leave that option unchecked once you build your game. But it is useful to use in the editor for debugging purposes. The next option here is the component manager ID, which simply, like the active grid ID and the world ID, uniquely identifies the component manager ID. Now I do want to mention here, probably should have mentioned this before. When the active grid and the component manager are saving data through this persistent data controller, the key that's used to save the data is a combination of the scene ID on the persistent data controller and the ID of the active grid or component manager. So for example, when you're saving the persistent data for this active grid here, the key would be video underscore AG, capital AG, which indicates it's for an active grid, underscore 0, and that's it. If you were saving persistent data for this component manager, it would be video underscore CM, which stands for component manager, underscore 0. Now you shouldn't need to change this component manager ID because you should only ever have one component manager in a single scene. So in some ways this component manager ID is sort of redundant. Nevertheless, we leave it there so that we can identify this component manager when we're saving persistent data. The last options you'll see here are these component prototypes. Prototypes are used to create new worlds and active grids during runtime. So one option you have for creating components during runtime is to use add component. The problem with this method is you could theoretically create an active grid or world and then assign it, for instance, a player, a boundary monitor, and a player mover. The issue is that the next time your gaming session starts, and let's say you've saved the persistent data after creating that active grid, the active grid that you created in the previous session would be created, but then you would have no way of assigning the player, boundary monitor, and player mover. So the solution is to use prototypes. A prototype is basically a pre-built component, either an active grid or a world, which you use to construct a new active grid or world from. So for instance, if we were using this active grid as a prototype, which is perfectly valid, you can use an active grid that is active in the scene. If we were using this active grid, a new active grid component would be created and assigned all of the references that this component has. So it would be assigned the first-person controller that's here. It would be assigned the boundary monitor, the player mover if there is one, the default world, and all of these other settings. Now when you're creating an active grid, you do have the option of specifying a alternate world to start sync to. So you don't necessarily have to have that new active grid use the default world. And also the component manager will automatically identify an ID that is unique. So there's no way to actually know what the ID of the newly created active grid will be in advance. But of course, after it's created, you can simply query that ID from the active grid. By the same token, let's say that we are using this world as a prototype. A newly created world would use the same primary object subcontroller and the same world grid. When you're creating a new world, you do have the option of specifying an alternate world origin, and that world origin is actually saved with the component manager data when it saves the list of all of the worlds that have been created at runtime. The world actually doesn't have any persistent data saved with it. So to add a prototype, simply change the number of prototypes from 0 to whatever you want, and then drag the prototype into the field. One thing to note is that if you're using a prototype that you don't actually want to be active. For instance, this active grid is active. We're actually going to use it, but you could have a prototype of an active grid that was just a prototype. You didn't actually want to use it in the scene. In that case, you'll want to deactivate the prototype, because if you don't deactivate it, it will be picked up by the component manager and set up and initialized, which will most likely cause issues for you. For now, we are not planning on creating any active grids at runtime, so we can go ahead and set that prototype value to 0. And that should cover everything. At this point, you're ready to hit play and see the dynamic loading kit in action. And I'll show you an example of that in the next video. Thanks for watching.